Hey there, and welcome to Massific Aptitude. In this video, we'll learn how to solve problems on LCM and HCF, the kind of problems that are generally asked on CAT and other aptitude tests, those for placement, government jobs, etc. Now, we'll begin with a few simple yet important questions, but we'll also look at some really good questions, and by the end of this video, you should be able to solve a variety of questions from LCM and HCF with ease and confidence. Also, for this video, I'm assuming that you already know how to find the LCM and HCF, and so we won't talk about the method of finding them. Just in case you need help with that, you can watch my other video in which I share methods and shortcuts to find LCM and HCF quickly in your head. The link is there in the description. This video, I repeat, is on solving problems involving LCM HCF. And before we get started, don't forget to subscribe to the channel and to press the bell icon. That way, when I upload more videos with useful tips, tricks, and questions, you'll get notified. Alright, time to dive in. We'll begin with a very simple question, a warm-up question. The HCF of three numbers is 15. One of the four options below is their LCM. Which one is it? 560, 460, 360, or 260? Can you answer this one? Go ahead, pause this video here, and let me know your answer with the logic in the comment section. So, what's the answer? It's C, 360. I wonder how many of you got that right. Anyway, the concept involved is that since the HCF is a factor of the three numbers, it must also be a factor of their multiples, and hence their LCM. In short, the HCF is always a factor of the LCM for a set of numbers. Or you can say it the other way. LCM is always a multiple of the HCF. Now, of the four options, only C, 360, is divisible by 15. And so, it must be the LCM. Got it? I hope you did. The next problem is also simple and straightforward. Don't worry, we have some great questions coming up later in the video. But this is also important. We asked to find the LCM and HCF of the given fractions: 4 over 15, 25 over 6, and 10 over 9. Now, if you can't solve this question, it's almost certainly because you don't know the formulae for the LCM and HCF of fractions. So let me write them for you. The formula for the LCM of fractions is the LCM of the numerators over the HCF of the denominators, and the HCF of fractions equals HCF of numerators over LCM of denominators. So when you're finding the LCM, LCM is on top and HCF is at the bottom, and when you're finding the HCF, HCF is at the top and LCM is at the bottom. So for the LCM, we have the LCM of 4, 25, and 10 over the HCF of 15, 6, and 9. Now, can you find these quickly without having to use pen or paper? It should not be too difficult. You know what? For this one question, let me quickly show you how we can find the LCM and HCF here. For the LCM, we go through the multiples of the largest number, 25. The smallest multiple of 25, that is also a multiple of the other numbers 4 and 10, will be the LCM. Also, we need not bother ourselves with the odd multiples of 25, because they cannot be the multiples of 4 and 10 which are even. So, only the even multiples of 25. Let's see. 25 times 2 is 50, but it can't be the LCM because it's not a multiple of 4. It's not divisible by 4. The next even multiple would be 25 times 4, 100, and it is divisible by both 4 and 10. So, 100 is the LCM. Then for the HCF, we try the factors of the smallest number, 6 in this case. And we start with the largest factor because we need to find the highest common factor. The largest factor of 6 is 6 itself, but it cannot be the HCF because 15 and 9 are not divisible by 6. 6 is not their factor. The next greatest factor is 3, and it works. 3 does divide into 15 and 9 evenly. So 3 is the HCF. So the LCM of these fractions would be 100 over 3. Then for the HCF, we have the HCF of 4, 25 and 10 divided by the LCM of 15, 6 and 9. We'll skip the calculation part. The HCF would be 1 and the LCM 90. So the answer would be 1 over 90. As I said, there was nothing fancy about this question. You just had to know these formulae and of course how to find the LCM and HCF. Nothing else. Okay, time for the next question. Find the largest number such that when 51, 29 and 37 are divided by that number, the remainders are 3, 5 and 1 respectively. Now, it is a question involving HCF. How do we know that? Well, whenever a question asks you to find a number that divides or is divided by a set of numbers, it is almost certainly a question involving HCF or LCM. This question talks about the greatest number that divides a group of numbers. So basically, the greatest common factor or the highest common factor, HCF. So, do we find the HCF of these numbers? No, because the question tells us that there are remainders. The answer is not a factor of 51, 29 or 37. When we divide 51 by it, there's a remainder of 3, which means that the answer is a factor of 51 minus 3, 48. Okay? Similarly, 29 minus 5, 24 is divisible by our number. And 37 minus 1, 36 is divisible. Now that we have got the numbers that are divisible by the answer, we just find their HCF. So what's the HCF of 48, 24 and 36? 12. This is the answer. Next question. Find the smallest number that when divided by 15, 25 and 10 leaves a remainder of 7. This time it's about the LCM. The question is about the number that is divided by these numbers. So we are talking about a common multiple, and because it says the smallest number, it is the least common multiple. Here too, there's a remainder involved, but we need to handle it differently this time. Let's first find the LCM. The LCM of 15, 25 and 10 would be 150. Now, being their LCM, 150 is divisible by all these numbers, and so there would be no remainders. In order to have the desired remainder, we must add it. So, 150 plus 7. 157. Answer. The thing to note is the difference in how we handle the remainder when working with the LCM versus when we have the HCF. Next question. Find the smallest number such that when it is divided by 12, 20 and 15 leaves remainders of 5, 13 and 8 respectively. In many ways, this question is similar to the last one. Here too, we are talking about the LCM. But there's one key difference. In this question, we have been given 3 different remainders instead of 1. And if you remember, in the last question, we added the remainder to the LCM. So which of these 3 remainders do we add this time? Well, none of them. Before we can go any further, let me introduce to you the concept of negative remainders. Consider the number 43. If you divide 43 by 10, you get a remainder of 3. This is a positive remainder, the type that we usually see. To get the negative remainder, just subtract 10, the divisor, from this remainder. 3 minus 10, negative 7. Now, what does a negative remainder mean? Let me explain. The 2 multiples of 10 closest to 43 are 40 and 50. The positive remainder tells us that 43 is 3 more than, 3 more than the lower multiple. And the negative remainder tells us that it is 7 less than the larger one. So both the remainders are meaningful and valid. It's just about which multiple you take as your reference point. Alright, now let's see how this idea helps us solve the question here. The question gives us 3 pairs of numbers: 5, 12, 13, 20, and 8, 15. The remainders and the divisors. These are positive remainders, but that's not the problem. The problem is that they are 3 different numbers when we would want them to be the same. So let's find the corresponding negative remainders. Perhaps those will come out to be the same. For that, as we just learned, we subtract the divisors from the remainders. 5 minus 12 is minus 7. 13 minus 20 is again minus 7. And lastly, 8 minus 15, negative 7. So we get the equal remainders that we wanted. From here, it's just like the previous question. We find the LCM of the divisors given to us and add this remainder. The LCM of 12, 20, and 15 is 60. Adding 60 and minus 7, we get 53, our answer. You can check it. If you divide 53 by 12, the remainder is 5. If you divide by 20, the remainder is 13. And if you divide by 15, the remainder is 8. Great. Next question. Find the smallest 4-digit number that, when divided by 22, 55, and 11, leaves a remainder of 10. This is not a difficult question, but it is tricky. It's very easy to make mistakes with such questions. You'll see in a moment what I mean. Alright, so at this stage, it should be clear that we need to find the LCM of 22, 55, and 11. That would be 110. But of course, this is not the answer for a couple of reasons. 1, there's a remainder to take care of. And 2, we need a 4-digit number, and this has only 3 digits. So, how do we go from 3 to 4 digits? Well, the important thing to keep in mind is that any number that is a common multiple of these numbers will either be their LCM or a multiple of their LCM. So in this case, we must take the smallest multiple of 110 that can get us to the required 4 digits. Let's see. 110 times 9 is 990, and 110 times 10 is 1110. So it appears like this is the smallest 4-digit number that we are looking for. But this is where people make mistakes. You see, we still have the remainder to add. And if you add 10 to each of these, you get 1000 and 1120. Now, this also becomes a 4-digit number. And being the smaller one, this is our answer. So be careful and make sure you've considered the remainder before you jump to any conclusions. Next question. The LCM of two numbers is 150. If the numbers are in the ratio 2 to 3, find their HCF. Here, the question tells us that the numbers are in the ratio 2 to 3. And so, let's assume that the numbers are 2k and 3k. Now, if the numbers are 2k and 3k, the HCF would be k. 2 and 3 don't have any common factors. The ratio was in its lowest terms. And so, k is the only common factor, and as such, the HCF of the two numbers. And this is something you should keep in mind. In cases such as this one, if the ratio is in its lowest terms, multiplying the terms with the HCF will give you the actual numbers. But the next question is, how do we find k? For that, we need to cover something else: the relation between any two numbers and the LCM and HCF. So here it is. The product of two numbers equals the product of their HCF and LCM. Simple as that. In case you didn't already know this, Note it down. It's very important. So 2k times 3k equals 150 times k. Now it's just about solving this equation. We know the HCF can't be 0, so we can divide both sides by k to get 6k equals 150 or k equals 25. So the HCF is 25. Solved. Next question. The sum of two numbers is 315 and their HCF is 21. How many such pairs of numbers are possible? This again is an excellent question and requires a very good understanding of the concepts. Here's how we solve it. First, it is given that the HCF is 21. So, both the numbers must be multiples of 21. Let's say that the two numbers are 21x and 21y. Now think about it. 21 is the HCF or the highest common factor for these two numbers. And so there cannot be any common factors beyond 21, which means that x and y must be co-prime, two numbers that have no common factors other than 1. This is important, as you will see in a moment. Alright, next we are told that the sum of the numbers is 315. So 21x plus 21y equals 315. Dividing throughout by 21, we get x plus y equals 15. So we are looking for two numbers that are co-prime and that add up to give 15. Let's see, if one of the numbers is 1, the other must be 14, right? Or it could be 2 and 13. Or 3 and 12? No, because 3 and 12 are not co-prime. They have a common factor, 3. But 4 and 11 is fine. 5 and 10? No, 5 is a common factor. 6 and 9? No. 7 and 8? Yes. And from here, the pairs will just repeat with the numbers interchanging positions. So we stop here. Now, if you take any of these pairs and multiply the numbers by 21, you will get two numbers whose sum is 315 and whose HCF is 21. And as you can see, there are 4 such pairs possible. So, the answer is 4. Before we move ahead, I must point out that I have seen people, including teachers, make mistakes in such questions. They completely miss the co-prime part, and as such, they count all of these pairs as valid. Of course, that means that they get the wrong answer. I hope you won't make such a mistake now. Alright, another question. Find the smallest number that when divided by 3, 5, 7 and 9 leaves a remainder of 2 but is completely divisible by 8. This is a very good question and there's a lot to learn. So I'll need you to focus. Now to begin with, let's forget this last portion of the question for a moment. Without this part, the question is a very simple one that we can solve easily. We just need the LCM of 3, 5, 7 and 9. For that, we can ignore 3 because its multiple 9 is already on the list. Then the remaining 3 numbers are such that no two of them have any common factors, and so the LCM would simply be their product. So 5 times 7 times 9 or 35 times 9, 315. Now, in the absence of this part, we would just add the remainder 2 and that would be our answer. But of course, we are not solving a part of the question. We are solving the entire question. And so, it's time to bring this back. The question requires that the answer be divisible by 8. So, is 317 divisible by 8? Certainly not. 317 is odd and it can't be divisible by any even number. So, what do we do? Well, like we did in one of the previous questions, we look for a suitable multiple of the LCM. Remember, only multiples of the LCM will be divisible by these. But what exactly do we mean by a suitable multiple of 315? Look, we'll be adding 2 to that multiple to get our final answer. And that final answer must be divisible by 8. So, we need a multiple of 315 that is 2 less than some multiple of 8. So we need a negative remainder, negative 2. But because we are not that used to working with them, let's convert this to a positive remainder. For that, we add 8, the divisor. Negative 2 plus 8, 6. So, the multiple we are looking for should leave a remainder of 6 when divided by 8. Alright, let's see what remainder we get when we divide 315 by 8. Well, 315 leaves a remainder of 3 when you divide it by 8. But we need 6 to be the remainder. And 6 is 2 times 3. So, the number we are looking for is 315 times 2, 630. Remember, when you double the dividend or increase it by any factor, the remainder also gets increased by the same factor. In this case, from 3, it will change to 6. Okay? So, 630 is the number we were looking for. It is a multiple of all these numbers, but 2 less than a multiple of 8. So when we add this 2, the resulting number would leave a remainder of 2 when divided by these, but it would be evenly divisible by 8. So our answer is 630 plus 2, 632. Now, if you had any difficulty in following the solution, don't worry. Just replay and go over it a couple of times and you should be fine. Also, there's something else I want to mention here. Say instead of 6, we wanted the remainder to be 7 in this step. 7 is not a multiple of 3. So what could we do? In such a case, change 3 into any number that will leave a remainder of 7 when divided by 8. So it could be 8 plus 7, 15, or 16 plus 7, 23, or 24 plus 7, 31, whatever, you get the idea. 15 would actually work for us since it's a multiple of 3. So instead of 2, we would multiply by 5. Hope that made sense. Great! So that brings us to the end of this video in which we looked at several good questions on LCM and HCF. If you found it useful, which I hope you did, hit that like button, share this video with your friends, and subscribe to the channel. Okay then. Until next time, take care, have fun, and keep learning.